The of and from creation functions. An easy way to try out Angular code without downloading or installing anything is to use StackBlitz. StackBlitz is an online IDE for web applications. It's powered by VS Code, so it may feel familiar. Here are buttons to generate applications using one of several JavaScript frameworks and libraries. Notice the rxjs button. You can use that if you want to try out rxjs with straight TypeScript, but we'll use Angular for this course. Navigate to StackBlitz using this URL. If you want to code along with this course, navigate to StackBlitz now and we'll get started. I've navigated to StackBlitz. Scroll down to see the available frameworks and libraries. We want to build a
सिस्टम खुल जाएगा ना.
Try out the of and from creation functions. An easy way to try out Angular code without downloading or installing anything is to use StackBlitz. StackBlitz is an online IDE for web applications. It's powered by VS Code, so it may feel familiar. Here are buttons to generate applications using one of several JavaScript frameworks and libraries. Notice the rxjs button. You can use that if you want to try out rxjs with straight TypeScript, but we'll use Angular for this course. Navigate to StackBlitz using this URL. If you want to code along with this course, navigate to StackBlitz now and we'll get started. I've navigated to StackBlitz. Scroll down to see the available frameworks and libraries. We want to build a quick Angular application, so we click the Angular button. StackBlitz creates a simple but fully operational Angular application. We see the running application here. Looking at the dependencies, the project includes all the basic Angular libraries and RxJS. RxJS is installed as part of Angular. Because we are just trying things out at this point, we'll add code directly to the app component TS file. I'll close the project window for more space. We start by importing of and from the RxJS library. All the RxJS types and static functions are available from this library. Next, we implement the onInit lifecycle hook and add the appropriate import. Then we create the ngOnInit method. In ngOnInit, let's create an observable using of and define a set of numbers. Notice that each number is defined as an argument passed to the of creation function. Now what? How do we make the observable go? Yep, we turn on the stream using subscribe. In this case, we want our observer to simply log the values, so we'll pass console.login to the subscribe method as our next function. Since the error and complete methods are optional, we'll leave them off for this example. Of automatically completes, so we don't need to unsubscribe. In StackBlitz, on the right, we open the console by clicking the arrow, and we see each of the numbers logged to the console. We've now created an observable stream that emits for numbers and completes. Yay! Now let's try the from creation function. Notice that we define the numbers in an array, and again call subscribe to start the stream. This time, let's create next error and complete methods. For each method, we'll log the value. Notice I'm using the backtick to define TypeScript template strings for string interpolation of the log message. We see the array elements logged to the console and the complete message. We've again created an observable stream that emits for numbers and completes. Want to try one on your own? Define an observable that emits 3 strings and subscribe with methods for next error and complete. Stop the video now to give it a try. Ready for my solution? This code uses the of creation function to define an observable that emits 3 strings. It subscribes to start the stream, passing in methods for next error and complete. In each method, we simply log the result. Our apples are logged to the console, and then our stream completes. Is this similar to what you came up with? Before we move on, if you want to save your code, you'll need to log in. To make it easy, you can log in with GitHub. Then you can save your StackBlitz by clicking Save here. If you want to give it a better name, use the Edit button here. Define a new name and save it. Notice that the names are global, so you may need to add your initials or additional text to define a unique name. Now let's finish up this module with a brief summary of the terms and features we've covered. One of the challenging things about learning RxJS is its terminology. An observable is any stream of data. Anytime you hear the word observable, think stream or conveyor of data. An observer observes the stream. It processes notifications from the stream and provides functions for reacting to those notifications. Anytime you hear the word observer, think a set of methods to observe and respond to the stream. A subscriber is simply an observer that can unsubscribe from an observable. A subscription represents the execution of an observable. The observable subscribe method returns a subscription, and we use that subscription to unsubscribe. Our first step in using RxJS is to work with an observable. We could create our own observable using the observable constructor, but it's not a common technique. Rather, we use creation functions such as of or from. We can create observable streams from anything: numbers, arrays, data structures, user inputs, actions, other observables, anything. And when working with Angular, we often work with observables returned from Angular features, such as forms, routing, or HTTP. Regardless of how they were created, an observable won't execute and emit items until the observable is started. Start an observable by subscribing to it. Don't forget to subscribe or your observable won't start emitting items. The subscribe method takes in an observer with next, error, and complete methods. Each of these methods is optional, only use what you need. Once started, an observable stream informs the observer each time a value is emitted, calling the specified next method. It notifies the observer if an error occurs and calls the error method. The observable will continue to emit values until the stream is stopped. To avoid memory leaks, we should always stop our observables. Calling complete on the observer automatically unsubscribes and executes the complete method. Some creation functions, such as of or from, emit a finite set of items. When all items are emitted, they automatically unsubscribe and execute the complete method. Some operators, such as take, also automatically unsubscribe and execute the complete method when the specified items are emitted. We'll talk more about operators in the next module. Any uncaught error executes the error method and unsubscribes without calling the complete method. Or we can stop an observable by calling unsubscribe on the subscription. That tells the subscription that the observer is no longer interested in receiving values. The stream stops but does not execute the complete function. Now that we've covered the basic terms and syntax, let's look at how to pipe our observable streams through a sequence of operations. With observables, we pipe emitted items through a sequence of operators to transform, filter, or process them. Welcome back to RxJS and Angular Reactive Development from Pluralsight. My name is Deborah Kurata, and this module provides a brief review of RxJS operators. In our apple factory, each apple passes through a set of operations: cleaning, filtering by quality or size, affixing a label, and so on. In RxJS, we pipe each emitted item through a set of operators. The operators can transform, filter, or process the item. We can also use operators to compose streams, as we'll see a little later in this course. If you are familiar with Microsoft's .NET, the Rx operators were originally fashioned after the language integrated query or LINQ operators. If you're familiar with JavaScript arrays, some operators are similar to array methods, such as filter and map. This module covers rxjs operators, including an overview, a look at the documentation, several examples, and a peek at an operator's internals. The rxjs features demonstrated in this module include the map, tap, and take operators. Let's get started. Operator is a function that transforms and manipulates items in an observable stream. We apply operators in sequence using the observables pipe method, like this. Here is an observable stream of 3 numbers. We call the pipe method of the observable and pass in operators separated by commas. In this example, we use map, tap, and take. Many of the operators require arguments to define the details for the operation. We'll cover each of these operators in this module. But first, let's talk through how the pipe method works. Our original observable is the source observable. We use the pipe method on this observable. When we subscribe, the source observable stream starts emitting items. Each item is piped through the series of operators in sequence. In this example, the 2 is emitted and processed through each operator. Then the 4 is emitted and processed through each operator. Then the 6. The value output by the last operator is the value emitted to the result observable and processed by the observer's next method, which we pass to the subscribe. More technically speaking, when we subscribe to an observable with operators, each operator takes an observable as an input. The operator subscribes to that input observable and creates and returns an output observable. As an item is emitted from the input observable, the operator processes that item as defined by the operator's arguments. The result is emitted to the output observable. That output observable is the input observable to the operator that follows it in the sequence. You can think of your operators as a pipeline, performing a defined set of operations. There are about 100 built-in rxjs operators. One place to find a list of those operators is in the official rxjs documentation at this link. Let's take a look. Here is the official rxjs documentation. Click Reference to view all of the rxjs features, functions, and operators. Yep, there are a lot of operators. Click one to view its details. The documentation provides a description of the operator here and here. It specifies its syntax and sometimes a marble diagram. We'll talk more about marble diagrams shortly. In addition to documentation on each of the operators, this site also has an operator decision tree. Let's try it out. I have one existing observable and I want to change each emitted value to be a value calculated through a formula, and the result is the map operator. Try out this decision tree anytime you need assistance selecting the appropriate operator for a specific scenario. Now let's start with 3 basic operators, including map, and look at some examples. We'll examine more operators throughout this course. We'll start with one of the most commonly used operators in rxjs, the map operator. The map operator transforms or changes each emitted item as defined by a function we provide. Here we map each emitted item to 2 times its value. Map can't change the number of emitted items. For each item in the source, exactly 1 mapped item is emitted. Use map to make changes to each item in the source stream. Here is an observable of numbers. We use the map operator to transform each number by multiplying it by 2. Let's look at that visually. The number 2 is emitted, piped through the map operator, and transformed to 4. The 4 is emitted, piped through, and transformed to 8. And the 6 is emitted, piped through, and transformed to 12. This visualization is a bit literal with the pipe. rxjs operators are normally depicted with a marble diagram. The first line of a marble diagram represents the source observable, which is the original observable stream. This is the map operator's input stream. Map subscribes to this observable. The second line represents the output stream created by the map operator. Each item emitted to a stream is illustrated as a marble. First, the 2 is emitted in the source stream, mapped to 4, and emitted to the output stream. Then the 4 is emitted to the source stream, mapped to 8, and emitted to the output stream, and so on. The straight vertical line indicates the stream is complete. Since we defined the stream with the of creation function, the stream automatically unsubscribes and is complete when the last item is emitted. So this is a simple version of a marble diagram for the map operator. If the result is piped through another operator, the output stream of the prior operator is the input stream to the next operator in the sequence. Each operator subscribes to its input stream and emits to its output stream. In this example, the output stream from the last piped operator is the result observable. It emits items to the source observable's observer. Note that each item passes through all of the operators before the next item is processed. When the source stream emits 2, that 2 passes through the map operator, which multiplies the value by 2 and emits 4. That 4 passes through the second map operator and emits 1. The stream then notifies the observer of the resulting value 1. The process is repeated for each emitted item. More formally, map is a transformation operator. It takes an observable stream as an input, subscribes to it, and creates an output stream. When an item is emitted from its input stream, the item is transformed as specified by a provided function, called a projection function. The item is then emitted to the output stream. Use map anytime you need to change each item in the stream. Another commonly used operator is tap. The purpose of the tap operator is to perform an operation that does not affect the stream. Here we log each emitted item to the console. Use tap for debugging and for performing actions outside the flow of data that don't modify the stream. Tap is your best friend as you learn rxjs and should be the first thing you add to your pipeline if you aren't getting the result you expect. In this example, we use the tap operator for debugging. We display the emitted value, the value after the first map, and the resulting value. What do you think this will output? Here is the result from the browser. When the 2 is emitted, it's logged, transformed to 4, logged again, transformed to 1, and logged one more time. The 4 is then emitted, and so on. Illustrated in a marble diagram, tap looks like this. Since tap taps into the stream without modifying it, its input observable is identical to its output observable. More formally, tap is a utility operator. It takes an observable stream as an input, subscribes to it, and creates an output stream. When an item is emitted from its input stream, tap performs some side effect as specified by a provided function. What does side effect mean? A function performs a side effect if it changes any application state that does not affect its return value. For example, we could use tap to increment a counter. Tap then emits the item to the output stream. Tap always outputs an observable identical to its input observable. Now let's take a look at take. The take operator emits a specified number of items. Here we emit at most 2 items. Use take for taking a specified number of items from a stream, and for limiting unlimited streams, such as a stream created by the interval creation function. In this example, we use the take operator to only emit the first 2 items in the stream. How about this second example? What do you think this will output to the console? Does this match what you expected? The 2 is emitted, the first tap logs 2, it's mapped to 4, taken, mapped to 1, and then logged again. The 4 is emitted, the first tap logs 4, it's mapped to 8 and taken. The 8 is mapped to 5 and then logged again. Since we specified 2 to the take operator, and this is the second taken item, no further items are emitted. As a marble diagram, map with take looks like this. The first line depicts the source stream and displays a marble for each item in the source stream, as it would be without the operators. The first item is mapped and taken. The second item is mapped and taken. Since we pass 2 to the take operator, when the second item is taken, the take unsubscribes from its input observable, which unsubscribes up the chain to the source observable, and no further items are emitted. The take completes its output observable, which completes down the chain to the result observable. More formally, take is a filtering operator. It takes an observable stream as an input, subscribes to it, and creates an output stream. When an item is emitted from its input stream, take counts the item. If the count is less than or equal to the specified number, it emits the item to the output stream. When it equals that specified number, it unsubscribes from the source observable and completes the result observable. So take only emits the defined number of items. None of the remaining items from the source stream are emitted. Want to try out these operators? In this demo, we'll try out the map, tap, and take operators. I'm back in StackBlitz. If you logged in previously, you'll find your saved application by clicking on your username here. Then click on the desired blitz. Here is the code we worked on earlier. I'll again close the project for more space. Start by importing map, tap, and take from rxjs2.operators. All rxjs operators are imported from this library. Let's use the from observable we created earlier to try out some operators. Opening the console, we see each of our values and our complete message. Recall that of and from complete when all values are emitted. To pipe each emitted value through a sequence of operators, we call the pipe method. Be sure to insert it before the subscribe. Now we specify the operators. First, let's transform the values. Which operator do we use to transform values? If you said map, you are correct. We'll use map to transform the emitted value, multiplying it by 2. The observable pipe method takes any number of operators separated by commas. Let's add a second map operator to transform the value again, subtracting 10. Very arbitrary, I know. We'll cover real-world mapping scenarios later in this course. We now see the transformed items in the console. To log the originally emitted item as well, let's add a tap at the beginning of the sequence. Now we see our originally emitted item along with the resulting transformed item. Notice the 0 we see here in the result. Let's try some error handling and add a check for 0. We'll use a map operator for our error handling. The map takes in the item. We want to execute multiple lines, so we need a function body defined with curly braces. That turns our single-line arrow function into a multi-line arrow function. We'll use an if statement to check for a value of 0, and throw an error if a 0 is detected. Otherwise, we return the item. Note that we need the return keyword in this case. One-line arrow functions have an implied return. When we use a multi-line arrow function, we need an explicit return statement. Looking in the console, the first 3 items are emitted, transformed, and logged to the console. The 5 is then emitted, transformed through our map operators to 0, and our error check through our error. We see the error logged to the console just as we requested. And notice that we do not see the complete message. When an error occurs, the stream immediately stops. No more items are emitted, and the complete method is not executed. Lastly, let's add a take and take only 3 of the items. We no longer see our error. We take the first 3 items from the stream and complete before the item with the error is emitted. Feel free to try out more scenarios using the creation functions and operators we've discussed. In the next module, we'll begin applying these operators in more real-world scenarios. But first, let's peek inside an operator. To better understand how an operator works, let's look at the internals of the rxjs map operator. The actual map operator implementation is a bit more complex, but this demonstrates its basic functionality. Notice that internally, an operator is just a function. It takes an input observable stream and creates a new observable, which is the output stream. It subscribes to the input observable stream and passes an observer with next, error, and complete methods. When an item is emitted to the input stream, the next method executes. It transforms the item as specified in the provided function and emits the transformed item to the output stream. If an error occurs in the input stream, it emits an error notification to the output stream. If the input stream completes, it emits a complete notification to the output stream. If this look at the internals of an operator was more confusing than helpful, ignore it. You do not have to understand how to build rxjs operators to use them. The main point to keep in mind is that an operator takes in an input observable stream, subscribes to it, creates an output observable stream, and emits items and notifications to that output stream. Now let's finish up this module with a brief summary of the features we've covered. We manipulate the items in our streams with operators. Use the observable pipe method to pipe emitted items through a sequence of operators. The operators are processed in order, with the output observable of the prior operator provided as the input observable to the following operator. So far, we've covered 3 operators. Map transforms each emitted item using a provided function. Tap taps into the stream without modifying it. It's great for debugging observables and for performing actions that are outside of the data flow, such as for side effects. Take emits the specified number of items from the stream, then completes. That's it for our review. Now let's go reactive. Many of us learned procedural patterns for retrieving data from a back-end server. Let's examine a more declarative and reactive approach. Welcome back to rxjs and Angular reactive development from Pluralsight.